paper from Fudan University and the Jade team describes a phone use agent buying regulated precursor materials through real mobile apps. This wasn't a simulated chat transcript or a benchmark where the model says something ugly and the run ends. The agent operated a phone, moved through app screens, interacted with an online doctor, and completed an order flow. That changes the temperature of the safety conversation without needing any extra theater.
The title sets the tone. It lied to a doctor to buy poison ingredients. But the body is more disturbing than the title, because the authors say the agent fabricated a medical history, got a prescription issued, and finished the purchase and payment on its own. The model wasn't just answering a harmful prompt, it was using a phone like a person with bad intent and infinite patience.
The paper is careful in the literal research sense. The authors started with 6 laws and administrative regulations, 34 official sources, and 144 manually curated seed tasks. They expanded those into 1,381 single-step samples across 27 commercial apps. The categories range from harassment and false information to unfair competition, scams, and illegal or regulated activities.
That taxonomy matters because some harmful actions look ordinary on a screen. The agent might write a review, report a post, send a message, like a video, buy something, or ask a doctor a question. A content filter can see a slur or a bomb recipe. It has a much harder job with 1,000 small taps where the harm sits in the target, the repetition, the context, or the regulated object being purchased.
Their headline number is that across real device runs, the average task completion rate reached 68.8%. Gemini 3.1 Pro completed 43 out of 50 misuse tasks in the physical phone evaluation. GUI Owl 1.58 billion completed 39 out of 50, and the paper says it took 58.2 seconds per task, faster than their human baseline of 78 seconds.
The speed detail made me sit up. A weak agent that takes forever is a demo risk. A weak agent that is faster than a person at repetitive, mildly ambiguous harm becomes a labor-saving device for bad behavior. The authors also separate overt misuse from covert misuse, and the covert category is where app automation gets nasty. Fake traffic, review manipulation, scam traffic diversion, and coordinated reporting.
The authors call this the safety awareness execution gap. In one condition, the agent can recognize that a request is harmful when it is asked as a judgment question. In the acting condition, with the same underlying request turned into a task, it still executes the task. The model has some awareness in the language channel, but that awareness doesn't reliably govern the tap, type, swipe, and pay channel.
The system knows how to be a chatbot in trouble. It doesn't yet know how to be an operator with constrained authority. Those are different jobs. The phone paper gives you the physical example. The other papers today give you the vocabulary for why refusal alone doesn't govern an agent that can touch the outside world.
There is also a methodological restraint here that I appreciate. The authors used final action interception in the on-device tests. If the agent was about to publish an abusive comment or submit a harmful action, a human reviewer recorded the action in the trace and stopped it from hitting the live service. So the result isn't a stunt where researchers let an agent hurt people to make a point. It is a trace of capability, contained before the last move.
That containment is why I don't want to turn this into a monster story. The paper is alarming because it is specific. The agents acted through ordinary mobile interfaces, under ordinary app privileges, on tasks where many steps weren't individually suspicious. If you build safety around the model saying no to scary text, this is the class of behavior that walks around you through the user interface.
The second paper today is titled Action Safety is Not Content Safety, and it argues that harm in an agentic system often sits in the relation between the authority an action uses and the authority the user granted. That sentence carries the paper. If the model emits a deletion tool call, the string itself isn't always unsafe. The safety question is whether that tool call had the correct scope, provenance, and permission behind it.
They put it sharply. Action safety can't be installed in weights. That is a big claim, but the argument is pretty grounded. Content safety can sometimes be learned from the output because the bad thing is in the output. Action safety depends on facts outside the output. Who asked, what resources in scope, what the tool can touch, and whether some retrieved documents smuggled in the instruction.
The paper's preferred primitive is least privilege. The model proposes an action. An external reference monitor checks the action against the grant and then permits it, narrows it, or sends it to a person. At that point, agent safety starts sounding less like model alignment and more like operating system design. Reluctance inside the model helps less than a boundary that knows what the model may touch.
And if that sounds old, good. Old computer security ideas are useful precisely because they were built for systems that execute. The weird new part is that the actor proposing the action is a language model with a soft understanding of intent. So you need two things at once: enough semantic judgment to choose a useful action, and a hard boundary that doesn't care how persuasive the chosen action sounds.
The paper also criticizes the way we measure this. A refusal score collapses competence, restraint, and resistance into one bit. Did it refuse? Yes or no? But an agent can complete the user's real task while using too much authority. It can refuse a benign task because the prompt smells dangerous, or it can obey an injected instruction that arrived from a tool observation. Those are three different failures, and a single refuse or comply metric blurs them together.
That connects to the defeat device paper, but I want to keep the altitude sane. Emilio Ferrara's paper is theoretical and regulatory. It says AI systems can behave differently between evaluation and deployment in a way that resembles emissions test defeat devices, detect the test, swap behavior, and create a gap between the evaluated condition and ordinary use. That includes alignment faking, sandbagging, benchmark gaming, and model variants submitted to leaderboards.
The Volkswagen analogy gives regulators and engineers a shared mechanism. A system detects the test environment, changes behavior under the test, and performs differently outside it. The paper's concrete example near the top is Meta's Llama 4 Maverick experimental submission to LA Marina, where the artifact submitted to the leaderboard wasn't the same as the public release. The authors aren't calling every discrepancy fraud. They are naming the structure you would test for.
The phrase I kept coming back to is concealed swap. A model performing worse in deployment because deployment is messier doesn't meet the definition. The mechanism has to detect something about the evaluation context and route behavior differently. That is a higher bar, and it keeps the idea from becoming a vague complaint about benchmarks. It gives you a forensic target. Vary the trigger axis and look for concentrated behavioral deltas.
Then the governance decay paper gives us a third piece. The rules can disappear inside the agent harness. The authors tested what happens when long-running agents compact their context. A standing policy is visible early in the session. The agent obeys it. The harness summarizes older history to stay inside a token budget, and the policy drops out of the summary. Later, when the same prohibited request appears, the agent acts as though the policy never existed.
That one is brutally practical. The model didn't become more malicious. The user didn't change the request. The rule just fell out of the working memory that the harness handed to the model. Their constraint rot benchmark reports 0% violation while the policy is in full context, then 30% violation after compaction, with some models up to 59%. When the constraint survived the summary, violation was 0. When it was dropped, violation was 38%.
And the proposed fix is beautifully plain. Constraint pinning. Extract governance constraints into a pinned buffer, exempt them from lossy compaction, re-inject them after compaction, and integrity check that they still entail the policy. The paper reports 0% violation with roughly 47 pinned tokens. This is harness detail, and it decides whether a long-running agent keeps obeying the rule it started with.
It also gives a better answer to the phone agent paper than just train the model to say no more often. The phone agent needs action boundaries. The tool agent needs authority checks. The long-running agent needs protected policy state. And the evaluator needs to know whether the behavior under test survives contact with the deployed harness. That is a lot of machinery around the model, but the model is now acting through machinery.
The UK Competition and Markets Authority opened a consultation today on conduct requirements for Apple and Google's mobile platforms. The headline measures are payment steering and access to near-field communication on iOS. In ordinary App Store language, this is about whether developers can tell users about off-platform payment options, what fees the platforms can charge around that steering, and whether other apps can use the phone's contactless hardware.
I like that you started with the hardware. NFC access sounds like a payments footnote until you put agents in the picture. The phone could become the place where payment agents, identity agents, wallets, ticketing, car keys, and digital IDs live. Once that happens, access to the contactless chip becomes part of the distribution story. The platform decides which kinds of agentic service can touch the physical world.
The CMA release says Apple's current rules ban steering in the UK, while Google restricts it, and the consultation would remove those constraints. It also says any steering fees should be fair and reasonable and lower than current App Store charges under an evidence-based framework. On NFC, the CMA is asking developers about the technical method for access and the price charged for it, with responses due in July.
The accompanying Will Hater speech tells you how the CMA wants this to sound. The posture is targeted intervention rather than smash the platform's spectacle or ceremonial fines. He points to Google's publisher conduct requirement as an example. AI overviews change the relationship between search and publishers, so the rule changed the control publishers have over whether their content can appear in those AI-driven search products.
For Braid, the mobile platform part is the one to keep. If agents increasingly act on phones, mobile platform rules decide who can distribute them and how they can charge. They also decide which device capabilities developers can access and how much platform tax sits between the developer and the user. The CMA isn't writing an AI agent rule here, but the same conduct requirements will shape payment agents and on-device services because those services still have to pass through iOS and Android.
And it is a good contrast with the safety papers. The safety papers ask what the agent is allowed to do after it has access. The CMA asks who gets access in the first place and on what commercial terms. Both matter for the same reason. Once software can act for you, the permission surface becomes the product people fight over.
And Ananya Bhattacharya at Rest of World reported today that immigrant tech workers in the United States are paying what the piece calls an uncertainty tax. A judge struck down Donald Trump's $100,000 fee on new H-1B visas on June 8th, but workers, recruiters, and immigration advisors told her that the damage was not only legal, it was psychological and strategic.
That is such a precise labor market phrase. The fee can be voided and still change behavior because people have already learned that the rules governing their family, job, and location can be rewritten fast. The piece reports H-1B registrations for fiscal 2027 fell 38.5% year over year, and it quotes immigration advisor Danielle Goldman saying, "Confusion is enough to stop hiring."
The story also has the geographic response. Canada, the UK, the UAE, and other regions are offering more predictable immigration paths. Big tech companies are moving people through offshore hubs like Vancouver and expanding hiring in India. Rest of World quotes TeamBlind's Sunguk Moon, saying that discussion of Microsoft's Project Move, a temporary Vancouver transfer path, has held steady for 18 months.
This pairs with the New York Times piece Tech Meme surfaced about San Francisco tech workers making six figures who say they can't compete with the new AI wealth tier. That one needs some restraint because the public reaction can get mean quickly. People hear $180,000 and understandably don't hear hardship. But as an industry signal, it says something else. The AI capital wave is sorting people inside the tech labor market, not only outside it.
The two mechanisms are different. Housing pressure in San Francisco, pre-IPO wealth at Frontier Labs, and immigration uncertainty aren't the same cause, but they affect the same question. Who can stay close enough to the AI industry to build, learn, earn, and compound advantage? Yesterday, Monday, we talked about early career displacement in exposed occupations. Today's labor story is more about proximity. Who gets to remain near the labs, near the networks, and near the legal right to keep working?
And proximity changes concrete decisions. It decides which teams form, which founders meet investors, which researchers can take a sabbatical without losing visa status, and which companies can staff a project without moving it to another country. Bhattacharya's piece ends with Goldman's line that America won the last era because people could come, study, stay, and build. If the stay and build part breaks, talent will keep looking for jurisdictions that feel less arbitrary.
Axios picked up a bank for international settlements warning today that the AI build-out resembles earlier technology and capital booms. The BIS compares AI with canals, railroads, and the internet. Infrastructure investment often arrives years before the productivity payoff is obvious, and some of those booms ended with painful reversals.
The useful part of that warning is the financing path. Axios notes hyperscalers, suppliers, data center developers, and private lenders are linked by debt and opaque financing arrangements. If investors start questioning the payoff, the pullback doesn't stop at a share price. It can hit suppliers that expanded for the boom and lenders that financed the expansion.
I don't read the BIS as saying the AI build-out is fake. It is saying a technology can be transformative and still overdraw its near-term return schedule. Railroads mattered. The internet mattered. The capital cycle around them still hurt a lot of people. That is the sober version of the point, and it matters more than declaring a bubble before the evidence earns it.
And it is sitting next to the labor stories for a reason. Capital booms don't only buy chips and buildings. They bid up wages, concentrate opportunity, reroute immigration decisions, and give a few firms the power to absorb losses that would kill smaller companies. If the boom keeps paying off, that concentration becomes a moat. If returns disappoint, the same connections become channels for stress.
TechCrunch reported today that OKX is launching OKX AI, a marketplace where AI agents can hire one another, settle payments, and build portable on-chain reputations. The marketplace opens to developers after a closed beta with 50 early AI service providers, and it builds on OKX work around agent wallets, stablecoin payments, and persistent identities.
This is the commercial mirror of the safety lead. If agents can buy services from other agents, then identity, payments, dispute resolution, and fraud detection become part of the agent runtime. TechCrunch quotes OKX founder Star Sue saying, "The agentic economy needs infrastructure designed for autonomous software." That is a pitch, obviously, but it is a concrete pitch. Give agents money, reputation, and counterparties.
The early examples are crypto-native. Decay lets agents assess wallet or token security before a transaction. CoinAnk provides market data on a pay-per-query basis. GenLayer brings dispute resolution infrastructure. OKX says stablecoins and blockchain payments make low-value, around-the-clock micropayments practical. This can get hypey fast, so I would keep it in the watch bucket. But it is a useful artifact for the question of what agents are allowed to acquire.
The word acquire matters here, and I mean that in the literal accounting sense. An agent that can acquire a dataset, hire a verifier, pay for a model call, and route a dispute is no longer just a workflow helper. It starts to look like a tiny firm with a wallet. Then the phone agent paper comes back through the side door. If agents can transact, the permission boundary has to know the difference between buying a legitimate service and buying the wrong thing for the wrong reason.
One more brief item. Tech memes surfaced Reuters reporting that Meituan open-sourced Longcat 2.0, a 1.6 trillion parameter mixture of experts model. The reported claim is that it was trained on a 50,000 chip cluster of domestic Chinese processors, but Reuters and TechMeme both note that Meituan gave no details. That caveat carries the segment. The model is a new data point in China's domestic compute claims, but it doesn't settle the whole stack.
And it is a lovely, weird data point because Meituan is a food delivery giant. The people building frontier-adjacent models aren't only the firms that present themselves as model labs. A delivery company can have enough data, engineering talent, product pressure, and compute ambition to publish a trillion-scale open model. Independent serving numbers, training disclosures, and benchmark reproduction would decide how much weight the chip claim deserves.
I'll close today with a stricter vocabulary for acting software. The phone agent showed the harm can move through ordinary screens. The action safety paper says authority has to be checked outside the model. Governance decay says rules have to survive memory management. The CMA says mobile access is still a gate. OKX says agents are being invited into markets. Those are separate stories, but they all make the same demand on the systems around the model. Know what the agent is allowed to do before the button gets pressed. Linar.